Good morning, class. Happy Tuesday. So today we're continuing to work on triangles, and we will be looking at unknown angles in isosceles and equilateral triangles. So if you have your anchor charts handy, you'll remember that an isosceles triangle is a triangle with two sides that are the same length, which means that two angles are the same. And an equilateral triangle means that all sides are the same length, which means that all of the angles will be the same. Okay, so we will also be using this anchor chart today. This is the final piece to our puzzle, and we will be evaluating these two rules. We'll be looking at them together and seeing that they are true. Okay, so the first rule is that the two angles facing the equal sides are equal. And the second rule is that if it's an equilateral triangle, all three angles are 60 degrees. Okay, so I have drawn on the board here some isosceles triangles. So let's look at them together. Okay, so here's my first one. And so I have my two little ticks that tell me that these two sides are the same length. Okay, so in order to find the two missing angles, we can use the rule that we know, that the two angles facing the equal sides are equal, okay? So that means that this angle is the same as this angle, okay? So we can figure out right there that this angle is 65 degrees, okay? Which means that our third angle that we need to find, we just need to do the math for, okay? So we're gonna do 180 minus 65 minus 65. Okay, which is 180 minus 130, which is 50. Okay, so our third angle is 50 degrees. Okay, so that's how you find the angle if you're given one of the angles that's on the base and is across from the equal sides. Okay, so what if you're given the top angle like we see here? So this one, here are two equal sides, right? And in this case, the angle that we're given is between them, which means that it's not across from them. It's not these two, which means that it is the third angle. It is the one that's different from the other two. So we know that these two bottom angles, let's call them A and B, are equal because they're the angles that are across from the equal sides. They're facing the equal sides. Okay? And that means we have to start with our 180 again. And we'll start by subtracting 84 degrees. Okay? Which is going to give us 96. Okay? And so that we know that the remaining value of the angles is 96 degrees. So what do we need to do? Because we know that the two angles at the bottom are equal, we're just going to take this number and divide it by 2, okay? Because we know that A and B are the same. They are equal. Okay, so we're going to take 96 and divide it by 2. Okay, and you're welcome to try this math on your own, but I will tell you now it equals 48. Okay, so each of these angles equals 48 degrees. Okay, do you see how that works? Okay, so if you're given the angle that is sandwiched between the two equal sides, then it's not one of the ones that is a pair, right? So you need to subtract the odd angle from 180, and then the value that's left, you can divide by 2 to find the remaining angles because they are the pair of angles and angles that will be the same. Okay? So now I wanted to draw your attention to this triangle. This, as you can see, is a right triangle, which means we know that this angle is 90 degrees. Okay? So can a right triangle be an isosceles triangle? What do you think? Yes, it can. If the two equal sides are this side and this side, because it's the same rule as here, right? Because we know that this is the only one that can be 90 degrees. So if it's sandwiched between two equal sides, then these angles can be the same, okay? And you can probably already tell me what the two remaining angles are, but I'll show you the math, because we know that when we have a right triangle, the remaining value is 90 degrees of the other two angles, right? And we know that 90 divided by 2 is 45 degrees, okay? So each of these angles are worth 45 degrees, okay? So there's your introduction to some isosceles triangles. Okay, so again, if you're given the angle that's across from one of the equal sides, you know that the other one that's across from the equal sides will be the same. And then you just have to find the value of the third, subtracting from 180. Okay, but if you're getting the odd angle, the one that's sandwiched between the two even sides, you need to subtract that from 180, and then you can split the difference. You can just divide it in half so that you can find the value of each of the base angles. Okay, and you guys know a right triangle can be an isosceles if it has the two equal sides on each side of the 90 degrees, so that these two angles equal 45. Okay, so now we're going to take a moment and look in our textbook. Okay, so please open your textbook to page 62. All right, page 62, and we're looking at the bottom here because we already had a look at these yesterday. So we're going to take a quick peek down at number 3, and it's asking us which of the following are isosceles triangles, okay? And so in order to find that, let's start with A. A, what we're going to do is just do some good old subtraction from 180 to see what the value of the third angle is, okay? So I'm going to just do it over here. So A, we're going to take 180 and we're going to subtract 38 and 27. And you may already be looking at this triangle and thinking to yourself, you know what, I don't think that that's an isosceles triangle because the remaining angle has to be a pretty big angle, right? So you can kind of use your critical thinking skills here and say, I really don't think that that's going to be isosceles, but we're going to do the math together anyways, okay? And we'll find that 180 minus 38 and 27 equals 115 degrees. So our unknown angle is 115 degrees, which does not equal either of the other smaller angles. So that tells us that A is not isosceles, okay? So we can draw an X beside that. But B, we don't have to do any math because we can see the two angles that they've given us are both 30 degrees. And right away, when we see matching angles, a pair of angles that are the same, we know that that's an isosceles triangle, right? But we can do the math anyways, just to confirm. So we have 30 plus 30, which is 60, and then we do 180 minus 60, which means that our top angle here is 120 degrees. Okay, so B is an isosceles triangle. Okay, and now let's look at C. C, we are given 30 degrees and 75 degrees, and we have a missing angle here. So we're going to do the math again. But again, you can kind of be looking at this triangle and using your critical thinking skills and making a guess as to whether this triangle is isosceles. Okay, and we will find that our subtraction, 180 minus 30 is 150, and then 150 minus 75 is 75 degrees. So our missing angle, our unknown angle here, is 75 degrees, which matches this other 75 degree angle. Okay, so C is also an isosceles triangle. All right. So there are isosceles triangles and how to determine if it is an isosceles triangle. So now let's look at number 4. So this is where we get into equilateral triangles, because equilateral triangles are very straightforward. They have one rule, and that rule is all 3 angles are going to equal 60 degrees. Okay? So when we look at this, here's our equilateral triangle with all of the angles labeled. So we have 60 and 60 and 60. Okay? Because they're going to be even. We know that they have to be even because all of the sides are even. So now when it's asking us which of the following are equilateral triangles, let's have a look. So P gives us 2 angles of 60 degrees. And so it's an equilateral triangle because the third angle has to be 60 degrees as well. So P is an equilateral triangle, okay? And Q, they've done a sneaky thing. They've given us 60 degrees and they've told us that 2 of these sides are the same. So we can start by treating this as an isosceles triangle and filling in the base angle here as 60 degrees and then doing the math to find that this one is also 60 degrees. Or we can just know that when one angle is 60 degrees and we have these 2 even sides, it's going to get us to an equilateral triangle. So Q is also an equilateral triangle. Okay, let's look at R. R, they've given us 2 equal sides, but then they've given us a 40-degree angle. So is R an equilateral triangle? No, it cannot be because all of the angles, our rule is all of the angles in an equilateral triangle are 60 degrees. So right away we know that that is not an equilateral triangle. It is, however, an isosceles triangle because we have our base angle and these 2 sides are equal. So we could find that this angle is also 40 degrees, which gets us to 80 degrees, which means that our top angle is 100 degrees. So you can see that that's an isosceles triangle, but it is not equilateral. Okay? So there's your rule for equilateral triangles. Okay, so if you're given something like Q, where it tells you 60 degrees and then gives you 2 equal sides, you can treat it like an isosceles triangle to start until you find that it's all 3 angles are 60 degrees. Okay? So let's look at number 5 before we go. So number 5 tells us that in triangle ABC, AB, so that's the line AB, equals AC, which is the other line. So they've given us the ticks to indicate that. And they've told us that ABC equals 35 degrees. And so it's asking us to find the other 2 angles. So let's do this on the board here together. So we're skipping right to 5. Oop. Okay, so we know that this corner is also 35 degrees. It tells us in the thought bubble. Okay, and we know that that follows the rule for an isosceles triangle. So all we have to do is 180 minus 35 minus 35. Okay, which will give us our third angle, which is 110 degrees. Okay, so that you could fill it in with the rest of the angles there. We have 35 degrees in the other corner. That's again across from one of the equal sides. And our remaining angle is 110 degrees. Okay. So there is your introduction to equilateral and isosceles triangle rules. And we are doing 2 exercises today, okay? We're gonna do exercise 41 and 42. So it's just 2 pages still, don't worry. Okay. And it's similar to what we've been doing before. So this page says that they're not drawn to scale, find the unknown angles. So you have to fill in all 3 angles and then mark each isosceles triangle with a check mark, okay? And we know that it's isosceles using our rule that the angles facing the equal sides are equal. So if you find 2 equal angles, sometimes they might not even label the 2 equal sides, but if you find 2 equal angles and a third different angle, then that's isosceles, okay? So if you find that, mark it with a check mark on this side. Okay. And then for this one, again, you're filling in the unknown angles, so make sure that all of them are labeled. And then mark each equilateral triangle with a check mark, okay? And so again, if it's an equilateral triangle, all 3 angles will equal 60 degrees. So if you find that on this side, give her a check mark to show that it is an equilateral triangle, okay? And of course, remember, our basic triangle rule is that all 3 angles will add up to 180 degrees, okay? So when you're looking for the unknown angle, you can subtract the 2 labeled angles from 180 to find it, okay? And as always, if you have any questions, please let me know. I'm more than happy to help, okay?